So imagine this. You're now in the middle of an intense mobile game. Your fingers are flying, your heart is racing, and then suddenly your phone just heated up like a mini oven. Ouch! It's hot! The screen lags, the battery drains. Game over. No way. So what happened? This is not just bad luck. When electronic devices work hard, they generate heat. And if the heat cannot escape fast enough, the entire system suffers. While many researchers focus on how to dissipate the heat efficiently, my work addresses on a more fundamental question. Is the material suitable in the first place? To answer this question, we firstly have to know how well this material can conduct the heat, which is what we know the thermal conductivity. And to measure it, for the basic principle, it's really easy. For example, if there are two samples with the same thickness, for the one that has a larger thermal conductivity can conduct the heat faster, right? So the temperature difference between the top and the bottom of the material will be larger. Okay, so if we know the temperature difference and the thickness of the material, we can easily obtain the thermal conductivity value through a simple math division. However, when we are dealing with the thin films, which are now used in a transistor or a packaging structure now in semiconductor industry, it's totally different. Because the film is too thin, so if we want to measure the temperature difference directly, it's almost impossible. So here's what set my research apart. We smartly use this voltage extraction technique to gain this tiny temperature difference and therefore to derive out the thermal conductivity value. And here's the trick. Because when the temperature changes, the electrical resistance will also change. So it will affect the voltage that we measure. So we use this relationship along with the specially designed circuit to later on gain the tiny temperature difference and therefore to derive out the thermal conductivity value. We have now successfully measured a wide range of the materials, and we are now combining this with the simulation tools to create a more comprehensive thermal analysis and prediction platform for next generation semiconductor material design and selection. So remember that hot phone in your hand. Imagine again, you are now using your phone without heating up. It runs faster, lasts longer, and stays cool. This is what we want, right? So by choosing the right materials into our devices, we can easily solve these hot problems and obtain the goal that I'm showing here. Happy devices, happy life. So that's the end of my sharing. Thank you.